Oh, Rush, hey, hello. What's up? Okay, the problem today is that I'm trying to solve is the following. I have this character. If the filtering for the image is linear, bilinear, and the problem is it looks kind of smooth. It doesn't look like pixel art. I want to look at like pixel art, but if I set the let's say that, for example, if I set the point filtering, it will look just fine except for this jaggery effect when I scale the image. I don't know if you can see it on the screen, but when I zoom it looks weird because of the aliasing. Your stream could be louder, by the way. I think you can add a couple of... and don't get into redness. Okay, I will try... okay. Interesting. Please let me know if it is... okay, I will do it. 1 second. I have this program here. Where I can increase the loudness. Yeah, I hope that it will be fine now. Yeah. So I'm trying to figure out this problem. How can I? It is very advanced problem. I have never written shaders like that. I don't know if you can see it on the stream, but right at the end of like the camera movement, those pixels jagger a little bit, or when I zoom in or zoom out. I don't like this problem at all. It gets worse when I zoom out and it looks weird. I don't want the pixel art in the game to look like this. Yeah, other than that, nothing too... not too much new things happened in the code base. Actually, I don't remember what has changed. I did quite a few things. Jitter-free pixel art scaling in Godot engine. It's 5 minutes. For now, I want to... I already created a shader. And yeah, I want to try... I want to try to create a custom shader for this exact situation. I just want to go on, almost on my own, maybe with the help of this article. But yeah. I just want to understand the algorithm. Okay, so I will turn off this thing. When I create the sprite, I will say that by default it will be bilinear. Yeah, it will be bilinear. Okay, yeah, so I just need to figure out how to do this. Yeah, as always, I don't know what I'm doing, but yeah, it's okay for me. Okay, let's think about it for a second. Maybe it will lead you in the right way, I don't know. In that video, he also wrote a custom shader. Okay, let's watch it. Let's watch it. Thank you very much. Let's watch it and see what he tells us. You know what? The thing is that when watching those videos, I do not understand. I cannot understand them quickly. I just need to... how do I say this? I just need to figure out those things on my own to understand them completely. But anyway, it's a good idea to watch this video and maybe I will get something from it. Okay, let's Google it. Jitter-free pixel art scaling in Godot engine. Okay. Okay, let's see. Let's look at it.
Nowość na Vinted. Kupuj elektronikę z drugiej ręki bezpiecznie i w bezkonkurencyjnych cenach. Pobierz aplikację.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to a quick little video about creating jitter-free pixel art scaling in the Godot engine. Let me show you exactly what kind of an effect we're going to get. You can see here on the right, this is a sprite without the shader applied. It will be done using a shader. And you can see this guy is kind of jittery, and the effect will be...
Yeah, this is the exact thing that I need to implement. I just need to make the game to skip when zooming. I just need this soft transition, sub-pixel transition. Yeah.
Better or worse, a little bit depending on your screen resolution, the resolution of your monitor. And so, but yeah, and then this side right here is much smoother. It doesn't have the jitter effect. And I think it looks quite a bit nicer. So first off, I want to give credit to two people. The first person is Acorian. He's in the Godot Discord. The shader code here, this function primarily it was completely written by him. He originally made this shader for 3D, for pixel art inside of 3D, and it works great there as well. And there'll be a link in the description to kind of credit him. I asked him exactly how he wanted to be credited and if it would be okay if I shared this code, and he said yes. So big thanks to him for sharing this code. I just made very, very slight modifications to make this work for 2D pixel art, pixel art inside of a 2D scene instead of pixel art inside of a 3D scene. So really the credit goes to him. The other person is the background that I'm using for this video right here. I found this on Open Game Art. It's a lovely little, he calls it a Gothicvania town. And he or she, I actually don't know. And the name is Asimus. And I should mention as well that I'm not sure whether or not Acorian is what their gender is either. But I guess I shouldn't assume that. But big thanks to both of them for helping with this video. I mean, I'm basically just sharing the work that they've done because I found it useful and I thought other people would find it useful as well. So make sure and check out the links in the description to see more of their work and to support them as well. So let's talk about how this...
Half the video gone and I still didn't get anything. But yeah, actually this is not a problem. Yeah, let's see what he is about to tell us.
What you're going to need to do is you'll need to have your sprite, and there's going to be... So I've got two sprites here in the scene. I've got the town left and the town right, as you can see here. In the town right, this image was imported using with filtering disabled, and that's usually what you want to do to create nice pixel art, because if you have filtering enabled and you re-import, you can see it's quite blurry. So usually disable filtering. However, with this shader applied, you can see if I click on town left, let me click on town left here, and we come back to import, you can see that filtering is enabled on this sprite right here. And that's because the shader needs to use the filtering. So if you disable the filtering, then it won't be able to work. So make sure when you import your pixel art that you leave filtering on, and then you can apply this shader. And the way that you apply it is if we come into our sprite here, I just clicked on the sprite for town left, there's a material, and this material is just a shader material, and it has a shader applied to it, which is the jitter-free pixel art shader. And that's all you need to do. You would need to apply that material to every single piece of pixel art in your game, but then when you're zooming, it's going to look nice and clean. The slight trade-off is that there is a slight fuzz to the pixel art at certain zoom levels, but it's very, very subtle. And I think that it's much better than seeing this very harsh jitter on this side. So that's going to be it for this video. You'll find all the links to...
Okay, basically in this video he doesn't explain the shader itself. No problem, no problem. At least we got the code for the shader. Yeah, I think it will be nice. I think it will be helpful. Actually, I never quite understood those derivatives here. Yeah. Yeah, I never understood those shader commands. Never mind, never mind. Let's see. So basically, I don't think I will need those either, because I think you need this part if you are doing some 3D stuff. I think that's the situation when you need the like those things. Yeah, I think that for 2D we will not need that. Anyway. I need to think about this situation in general. Yeah, here are some visualizations. Like, you will have no problems if you scale, by integer amount. For example, here he scaled this image like he scaled this image 2 times, and that is why it looks good, right? But here he scaled it. You see, here is the size of 3. Here is the size of 6. Here's the size of 3. Here's the size of 7. And you see, that is where this jittery effect appearing. Yeah. When using bilinear filtering, I'm sorry. I'm sorry. It is always too hard to remember this, but I need to try to remember those things. Yeah, basically, here's the size of 3, here's the size of 6, here's the size of 3, and the size of 7. And this jitter effect appears because, you see, when all of them should be 3, yellow, red, it appears that in this situation, they will be like 2, 3, 2. And yeah, one can think that this problem could be solved by bilinear filtering, but as we saw, the bilinear filtering is not working because it tries to interpolate between the pixels of the image, right? And I think it should be like interpolating between the pixels on the screen. Interesting. Okay. But how do I know how much pixels on the screen any particular pixel is taking? I don't know. I don't know. Yeah, basically it should look more like this. Now that we are gone through how nearest neighbor and bilinear filtering work, we can move on to the pixel art scaling shader. As I mentioned earlier, this shader works by combining both nearest neighbor and bilinear filtering. For the most part, the shader uses nearest neighbor filtering, as this is the best suited for pixel art. However, I don't know. Actually, I don't know the answer for this question. I don't see any reason to leave the filtering enabled, because basically all the filtering will be happening by the will be made by the shader itself, and I don't know. I don't see any reason. Yeah, I don't know that. However, the borders between text cells bilinear filtering is used. This is because if a screen pixel is situated at one of those borders, it would contain parts of more than one texel. Remember, if we were to use nearest neighbor, that pixel would have to choose the color of only one of the texels, making the pixel art look distorted. The use of bilinear filtering at the borders blends the colors of the texels that share the same pixel, making it look more natural. This will not cause a noticeable blur like pure bilinear filtering does, since we only use it at these borders. An example is shown in the diagram below. Okay, let's look at the shader code that they want to provide us. Location within texel. I already do not understand that. Fraction of input texture coordinates. What? Input texture coords. Aha. Texel size. Okay. Okay. Wait a second. Here is the image. If I scale it, what should happen? I think we will anyway need some kind of texel size. Texture size GLSL. Texture size. Okay. Okay. Texture 0. What this will give me? This will give me like 1 divided by the size of the texture, but this size is not the size which like this image takes on the screen. This is the size of the texture itself. Okay. Is there any way to get the size of the texture in GLSL on the screen? I forgot. GLSL functions, built-in function. Okay. This is texture. I do not have access to the vertex shader. I think I could this information from the vertex shader, but something tells me I cannot get it from here. I don't know. I don't know how to approach this problem. Yeah, in RayLib I do not have access to the vertex shader. Okay, let's see. Location within Texel. Um, one more question that I'm interested in is how do I know if I am at the edge? How do I know if I need to interpolate between? Wait a second. Yeah, I think that in order for me to... Oh my god, I'm stuck. I am stuck. I don't know. Okay, let's see what are the errors. Ah. Okay. Fail to compile unexpected. Unable to find compatible overload function. Ooh, wait a second. Texture, size, GLSL. LOD. Should it be like this? No. Failed to compile fragment shader code, compile error, syntax error, unexpected undefined token. 17. Ah, oh my god, sorry. Okay. Let me think. This is why I never like made any successful game so far. It's because I'm thinking for too long. It's because I do not want to copy the existing solutions. I just want to understand everything. But at this point, I really want to understand how this works because I think it will be useful for the future. Yeah. So basically they do not... I thought that the solution would be to take nearest pixels, sample them, and interpolate manually. But it doesn't look like they do that here. It looks like they just modify the UVs and it somehow works. Try to get help from the no, wait a you know, I could use ChatGPT, but I think I will solve this on my own. I just need to understand a few things. It doesn't look complicated, actually, this problem. Like, the problem for me is to understand the problem completely. I don't think I do that at the moment. Yeah, bilinear interpolation doesn't work because in bilinear interpolation they interpolate between the original pixels, those big dots. They don't interpolate between the pixels on the screen. All right. Okay, let's see. Nearest neighbor filter is simplest way to scale it. You're basically just taking the pixels from the texture and making them bigger to form the scaled image. This is done by giving a pixel in color as the nearest texel. The algorithm for performing nearest neighbor filtering is illustrated in the diagram below. Of the texels by a point at the center of each texel. This is then stretched to the size of the final scaled image and overlaid onto it. Each pixel in the scaled image is also represented by a point in its center. Next, for each point in the scaled image, the nearest point in the texture is found. Okay, yeah, I understood that. In the diagram above, the scaled image turns out perfectly since it's an integer multiple of the texture. In this case 2, yeah, because they scaled by 2, it is perfect. However, if the scaled image is not an integer multiple of the texture, the final product won't turn out quite right. See this diagram below for an example of this. Here the texture is still 3 by 3, but the scaled image is 7 by 7. In the scaled image you can see that some of the texels show up in different sizes and shapes, since it's slightly larger than an integer multiple of the texture. Okay. With bilinear filtering, instead of making the texels bigger to form the scaled image, you are blending the colors of the texels in the space between them. The term bilinear refers to blending of colors in both X and Y. As with nearest neighbor filtering, the bilinear filter algorithm starts out by taking the set of points representing the texel, stretching it to the size of the scaled image, and overlaying it onto the set of points. That's why I'm unemployed. I forgot to respond to this note from Yurish. I think that it is important to understand everything at the low level. At least, like, now I'm 28. years old, and you know, I've been working for companies like for starting from 2017, quite a long time ago. Um, yeah, and what I understood that the company doesn't want you to know too much things. They just want you to get the job done that needs to be done. And quite often this job is not interesting and does not require you to know too much things. When But that is why I think it is important to understand all of those small, tiny, little things which no one cares about. I think if you really want to know how something works, you should learn it. You should do what you are really interested in. I think, yeah, I think programming is in general is quite an interesting thing because you solve too many small tiny problems, especially in game development, because in game development you do a lot of stuff like graphics, physics, you're doing I don't know, collision detection, sound, like too many things, and yeah, it is really interesting. Even now, when like trying to solve this problem, your brain is working, and if your brain is working, it it is good. Okay, back to our thing. Okay. I think if we implement this algorithm, it will even make our world image to look better. I really do think so. We will see. Yeah, but how do I know the size of an image on the screen? How do I know that? How do I know that? Actually, I think I can calculate it manually when rendering the image. Yeah, somewhere here when rendering the image. Yeah, I see. Position screen, draw texture. I think image size, destination image size. Is it in pixels? I forgot. Yeah. Yeah, it is in pixels. Oh my god. Destination image size. Yeah, nice. It is a good thing to know, to be honest. Wait a second. What I will do is that I will go to my shader and I will add one uniform. I will call it vector 2. I will call it texture size on screen. Texture size on screen. Okay. Right here I will do what? I will say that I want to RayLib get uniform, get location, get shader location, render shader pixel art, texture size on screen. Okay. Size on screen location will be equal to this. Then what I will do is that I will say RayLib uniform set uniform. I already forgot how to do this. Wait a second. Set shader value. Set shader value. I will set it on the render shader pixel art location. Size on screen location. I will take the address of image size. No, sorry, destination image size. And the uniform type will be vector2. Nice. Okay, I think half of, like, I think one part of the problem is solved. Let's say that, oh, vector2 pixel size. Will be equal to 1 divided by 1 divided by the texture size on screen. Okay. Okay, I think this will be useful. At least I hope so. Yeah, so what I've calculated is how many of those pixels? How many of those small pixels I will wait a second. How many of those small pixels I will have, yeah, on the screen for this image? Okay. Yeah, so basically I now have two things. I have texel size, which is like the size of the texel of this thing. Basically the big square here. Yeah. And wait a second. Yeah, so yeah, I have the size of this big, which is a texel size, and I have a size of this small, which is a pixel size. Okay, what should I do then? In places where I need to interpolate between those now. Like, if I have a pixel, which is yeah, I don't know. I do not understand the problem completely. Maybe I do not understand what the pixel is and the texel is. But if I understand correctly, pixel is what you have on the screen, and texel is what you have from the texture. Because when putting an image on the screen, okay. Yeah, I am starting to forget to put those semicolons. When putting a texture on the screen, you see there are such situations like, for example, here, this texture like is taking half of my screen, say 700 pixels, but the original image is only 32 pixels of size. Yeah, so texel is what you have from the texture, and pixel is what you have on the screen. Yeah, I'm just saying it out loud because I'm trying to convince myself that I understand those things. But yeah, in such situations, I'm starting to doubt if I know all of those things. Yeah. Basically, now the problem is where should I interpolate? Because this pixel is okay, but this for some reason is interpolated. And why should it be interpolated? Because it touches this line or what? It looks like it is. Yeah, it looks like those pixels which are on the boundary of texels, right? Those pixels which are on the boundaries of texels, they should be interpolated. Okay, okay. Okay, it makes some sense, I think. It makes some sense, I think. Okay. But how do I detect that? How do I detect if the pixel is like fully covered by a texel, or is it touching this boundary? For some reason I'm too slow on such things. Okay, let's do the next thing. Vector 2 texel coordinate will be equal to texel size times fragment texture coordinate. I believe that's correct. Okay. What this will give me? This will give me a location of not this point, not this point. I will get the location of this point, like Anyway, I would get the location of those texels, and this will tell me where should I sample from. But again, I do not understand how do I check if I need to interpolate? How do I check if I'm on this boundary? Please, please, please. Focus, focus. Ugh. Okay. Okay, what I have? I have this texel coordinate. I believe that in order to calculate this texel coordinate better, I will need to add half of the texel size. Plus texel size times 0.5. I'm starting to doubt if this is the correct thing to do. How do I get this texel coordinate the correct way? It will be something like wait a second, I think I will need to do something like this. I will need texel coordinate equal to fragment texture coordinate. Okay, sorry, I'm tired of this repeating music.
Pojemną masz tę lodówkę, tyle jedzenia to chyba zapasy na dzień.
Weekend.
Oh my god, this is the game of my childhood. I really like to play Oblivion. Yeah. Yeah, the game of my childhood. Okay, fragment texture coordinate times divided by the texture size. Yeah, I know, the Skyrim music was good, but I'm tired because it was repeating. I want to hear something else. I wonder if he will meet some marauders, like robbers. Interesting. Ah, okay, never mind. Yeah. Okay, back to our problem. Okay, let's see what they're doing. Texture coordinates, texel size. Input texture coordinates times texel size. This makes no sense to me, actually. This is what... let's visualize our texture coordinates. I want to understand them better. How will we do this? Let's say that for now I will comment this. I will say that out color will be equal to vector 4 fragment texture coordinate 0 1. Some errors, of course. Ah, okay, once again I forgot to put the semicolon. Okay, okay. This makes sense to me. This makes sense to me. I've expected that. Basically, it means that our texture coordinate is going from 0 to 1 here and 0 to 1 here. That's what I expected to see. Yeah, now it should be a texture once again. Okay, let's see. Location within texel. Location within texel. They take the fraction of input texture coordinates. Yeah, okay. Interpolation amount. Oh, okay, location within a texel. What it is, once again. Location within a texel. Will it be something like the relative position of those points related to the start of the texel? I think maybe yes. Interpolation amount. do not understand that. Interpolation amount, clumping location within texels divided by texels per pixel. Okay, if you divide the location within a texel by texels per pixel, we will get pixels. So basically he wants to get I don't know. And he's clamping this between 0 and 0.5. Why? And then he's also clamping I need to understand this. This should be something really straightforward. I need to understand this. I think here's where all the magic happening related to detecting this thing. Oh my god, this is difficult. Oh, this is simple, but for me it is like difficult. Okay, why is he clamping to 0.5? Huh. Okay. Yeah, basically today is such kind of is a kind of day where I'm struggling on one thing. Oh, he walked in. He walked into the city. Yeah, I really like this game. Yeah. Yeah, you know what? Not on all the streams I will make too much progress. I need to... How do I say that in English? Wait a second. Okay, never mind. I just need to... Never mind. My brain is not working, as always. Okay. Location within Texel is equal to the fraction of input texture coordinates. Line 4. In line 5 we convert the texture coordinates from range 0 to 1 to range 0 texture size. Exactly. This is what I've been doing right here. No, sorry. Yeah, I should do it like this, of course. Yeah. How do I take the fraction part? It looks like there is a function called fraction part. Location within Texel equal to fraction Texel coordinate. It compiles, it's okay. Okay, it compiles. What's next? Okay, now when I know the location of the location within the Texel. Yeah, like the last thing that I need to figure out is how to figure out this. If this boundary, if this texel boundary touches the those pixels, and how do I tell those pixels inside which are not touching? How do I tell them to sample from the original texel? Yeah. I think I'm close. I think I'm close to understanding that. Yeah. I think I'm close to understanding that. Wait a second. I think I could have just took location within Texel. Location within Texel. Interpolation amount. Oh my god, why is it so difficult, man? I do not understand that. Why is he dividing, subtracting 1, dividing by texels per pixel, and then adding a half here? I don't understand that. Like, for example, let's say if the texel location was here, I was about to subtract 1. Divide by wait a second. Hmm. Okay, I will try to read through this explanation. Remember that in the vertex shader we converted the range of the texture coordinates. So all texture coordinates here have texels as the unit. So in getting the fractional part of the texture coordinates, we are getting the fractional texel value where the screen pixel is located. As an example, if the coordinates were, we would assign it the value. In lines 4 or 5 we are using location within texel value and the texel per pixel value to determine how much interpolation to use for this pixel. In most cases we will end up choosing an interpolation amount which represents no interpolation, since it's at the center of the texel. However, if the screen pixel is at the location where it partly lies within different texels, we will want to do some interpolation. An interpolation amount would represent the maximum amount of interpolation, since those points lie at the corners between texels. Okay. Okay, I understand this. I understand that. Location within texel. Interpolation amount. Yeah, basically everything leads to how do I detect if I'm at this edge. Okay, let's see. Let me calculate the pixel coordinate now. How do I do that? I have let's say vector 2 pixels per texel equal to pixel size divided by texel size. Okay. Now pixel coordinate will be equal to Texel. Texel coordinate times pixels per texel, right? Now, what I got is that I got this like top left of the pixel. Okay, it's okay. Now when I have this, I think I somehow need to modify this coordinate to do what? Aha! Wait a second. I think I am starting to understand that. I think. Okay. Yeah. I think I'm close. I think I'm really close to understanding that. So this pixel coordinate, what it is? Texel coordinate? Okay. Wait a second. I need to get the coordinate of the pixel in the texel space. The coordinate of the pixel in the texel space. Basically, if this was 0, this was 1, this was 2, I need to somehow be able to tell if this is 1.1 or something like that, you know? Pixels per texel. I think I need to have this the other way around. I think I need to have a texels per pixel, because this will tell me how much of the texel each pixel takes. Yeah, this will be something like that. Okay. Okay, and now pixels per pixel. Now to get the coordinate. Wait a second. Ugh. Oh my god. Okay, pixels per pixel. Pixel size divided by pixel size. Now, what can I do with this? Yeah. Wait a second, wait a second. So, what I have at the moment, I have the coordinate of the texel. No, I have texel coordinate. Yeah, I have the texel coordinate. Oh, it is so complicated to put it all in my head. What do I mean I have a texel coordinate? Like when rasterizing pixels on the screen. I have the coordinate. The location within texel. Oh no, this is too complicated for me.
How are you?
I'm fine, thank you.
How are you? How are you?
A rude man. He answered nothing. Phew. Oh, today is not my day. So, location between pixels divided by pixels per pixel.
A pretty cell got nothing to eat.
A pleasure to see. May I help you?
Greetings, Argonian.
This had better be good.
I do not understand what I see on this image. No, really. I do not understand a few things. Why those dots are on the center of those squares? I don't think I understand that. And what do they represent? I think I understand. Okay. Never mind. I'm too stupid. Pixels per pixel. Yeah, my idea was that maybe if I get the coordinate of the pixel, inside a pixel. Wait a second. Yeah, if I get the coordinate of this pixel inside a texel, basically now I have the location within texel of those points, like in relation to the texel. Now if I divide if I divide the location within texel by texels per pixel, what will I get? I will get some number. No. Aha, wait a second. If I will divide this, like 0.1 by the size of the texel, I will get some number which will be quite small. Which will be quite small. Okay. Okay. And the thing is, unless this result that I will have, unless it will be greater than I think I'm starting to get it. Unless it will be less than a half, unless the result of division of the coordinate of the pixel inside the texel, unless it will be smaller than then 0.5, we will need to interpolate. clamp location within text on -1. Okay, okay. Yeah. You see, for this pixel, it is really far away. Like, the coordinate of this pixel... How do I tell this? How do I even put this? Wait a second. Pixel coward. Let's say it will be equal to the location within Texel, to location of either of those pixels. Okay, location within Texel divided by Texels per pixel. Okay, and if okay, let's say coward 1. Okay, let's Google GLSL clamp. Can I clamp vector values? I think no. We will see. Okay, I wrote this because, like, we will not need to clamp if this coordinate is further away from this boundary by a half of the pixel. You know, you see? Yeah, I think that makes sense. For example, in this situation, the location within Texel is quite small, and when dividing it by the Texel size per pixel, by texels per pixel, yeah, I will get, for example, here I will get something like, for this pixel, if I divide its location by the size of the texel per pixel, by this size, I will get something like 1.6, right? Or not? Ah, no. Wait a second. I will get 1.1, something like this. But this is still too far away. Yeah. This makes sense to me. But here's one. Right now I've just checked related to the previous, like for this. Okay, I need to think one more time. What do I want to say? What do I want to say? How much time is it taking? Oh my god. Oh my god. It's taking too much time. Now I need to also check this distance. And how do I do this?
This is a holdup. Hand it over or die. Thanks. Until next time.
He gave him money or what?
Thanks. Until next time.
Yeah, really. He gave him money. Oh my god. I never gave them money. I always fought with them.
Make it quick. Enough.
He killed him. Oh my god. He gave him money and then he killed him. Oh man. That was brutal. Oh my god. Okay. Oh my god, I'm so bad. I'm so bad. I think I will do it or something like this. Okay. Now I maybe need to add those slurp factors. I don't know if I'm doing that correctly. Okay. Okay.
Księgowi, mamy nowych klientów, a wy jesteście księgowymi z polecenia! Okay, I think that now I need to just somehow figure out how do I get texels. The nearest texels with which I want to interpolate with. Or something. Okay, how do I get... I know how much I need to interpolate, but between what? I need those texels somehow. Wait a second. I'm really close. I'm really close to finishing that. Really, really close. Yeah, basically we need to modify. We need to somehow add. If in the origin, when originally rendering the image, it was blurry because we were sampling bilinearly from those points. We need to somehow add. We need to somehow add to this texture coordinate. We need to. Ah no, here we need to interpolate. But to these. To these. We need to somehow modify their texel coordinate to coordinates to sample from here. Yeah. Yeah, I see. Ah, now I understand what this means, what this floor means. Yeah, now I understand, I think. Yeah. Yeah, and we just add here interpolation amount. Yeah. Basically here we are resetting those coordinates and just adding these. Yeah, I understand. I finally understand what is going on here, except for one thing. Yeah, so here it will be 0, 0f, 0.5f, because, yeah, just because I will clamp the coordinate of this pixel between these. Um, yeah. Wait a second. Yeah, I understand. I need to only understand how to compute this at the end, because this, I believe, will not be correct. Maybe it will. Wait a second. Wait a second. Phew, I'm really close. I'm really close. I feel it. Okay, so no. Okay. Like, I'm sure that I'm computing the LORP factor for the for this pixel correctly, for this correctly here, but not for this one. Wait a second. So here, what I should do? I need to do something which will so here it will compute 0.5 on X right here for this pixel. Oh, wait a second, I'm so close, I'm so close. I think I even know the code that I need to write, I just want to make sure it makes sense in my head. Yeah. I think it makes sense to me now. I will do what? Okay. I add those, and finally I will do what? I will vector to result text covered will be equal to floor the texel coordinate. I will do it plus result lerp factor. I will divide that by the texture size. Texture size. Okay. And finally I will pass result texture coordinate. Yeah, something like that. Let's fix the errors. Interesting. It works and it doesn't work at the same time. I still see that jittery effect. Weird. No, I still see that. Let's verify. I will remove this code. Create sprite. No, I still see that. Interesting. Okay. Yeah, it is weird. It is weird because I think now everything is correct. I'm quite sure. I can even verify it with this implementation. Yeah. It is exactly the same. But like it is better to some degree. Something. Huh. Interesting. That is why coding games is difficult. It should work, but it isn't working. Yeah. Let's see what the debugger tells us. Seemed decent. Yeah, but not really. It looks great, but I still see that jaggery effect, and I don't know why. I just want to see. It's destination image size. Let me scale it a little bit and see it once again. Yeah, it is it is bigger now, and yeah, you know, it is quite expectable. Yeah, I think that is correct. I think that is correct. Texture size on screen. Wait a second. So I do have this texel size and pixel size. Texels per pixel. I think that the last thing that I need to make sure is that I've computed this texels per pixel correctly. Right, I need to verify that, and texels per pixel. How do I do that? Basically on the screen I now have the image of size like 600, but it is like 20 times bigger than the original texture. So it should be like 1/20th texels per pixel. Yeah. Here we go. Oh my god, yeah, it is working. Finally. I just... Oh, yeah. Oh, shish, man. Oh my god. It is working. Ooh.
Yeah, I just... it is good that I decided to verify that, because it was looking correct, but it was not correct. Oh my god. It was something like this. Yeah. And it is jaggery. Now... Oh yeah, man. It is now super great, super good. Oh man. Holy shish. Holy shish. Now we are drawing some good pixel art. It is super nice. It is... Oh man. It is just great. It is just great. I don't know what to say. Yeah. It works. It works. My friends. Oh my god. Yeah, it is working. Finally. Yeah. It is working. It is working great. Flappy Bird. Woohoo! Dima the professional. No, not really. Holy man, I don't know how. Yeah, it is working finally. Oh my god. Oh. Was it worth it spending like 2 hours? I think yeah. It looks better now. At least it is not like cutting my eyes with those jaggery effects. I don't know. Yeah, now it looks quite satisfying. Quite satisfying. Oh my god. Yeah, it looks great. It looks great. Yeah. I don't know if I want to do anything more today. Actually, yeah. Today is not really that productive, but oh, I can do a commit. Wait a second. Where you will you make video about this success? Not really. I don't think so. Maybe I will make a video later
when I add more stuff to the game, but to be honest, I didn't record any videos up to this point. Maybe it's too late to think about those things, but maybe, yeah, I will start. I don't know when. I don't have time. If I have time, I would better spend it on making a game than making a video, I think. I do not want to be successful YouTuber at this point. I've been trying to do a lot of YouTube stuff in the past, but you know, it is not mine. I do not like to edit videos. I do not like the process of like recording my voice for the video. And I cannot be myself speaking in English. On the stream it is okay, but in videos, you know, you have to provide content as quickly as possible. You should be yourself, and I cannot do this. I meant about this shader. To be honest, I don't think so. I don't think there's a need. I think people who want to implement it will find this article, and I think it is great. I'm making video about fixing this problem. I think it is not too many people are interested in such things, so I think I will not do that. Yeah. I don't think too many people will want to learn how to do that. Yeah. But I'm really happy with what I have at the moment. Really, really happy. One more thing that I want to do in the future is to improve movement, because I don't like the way it is stuck and I cannot move to the left at the moment. For example, here I'm trying to press a button to move to the right and it doesn't move. It isn't moving. I don't like it actually. I will definitely have to spend a lot of time like modifying the movement logic and maybe implementing, I don't know, maybe implementing the mesh sampling for the points that the character can walk on to reconstruct the movement vectors that the character should follow. I don't know, it is difficult for me to think. I just don't like the way it is made currently, because you see there is a situation. I'm trying to press right for him to walk to the right and he's stuck in the wall. Yeah, I will definitely need to do something here. I don't know, this should be some very smart things. I don't know how to do that. But actually, this is nothing in relation to the multiplayer stuff. I have never implemented any multiplayer logic in my own games, so this will be the real challenge that I will have to face. These things that we had today, it is simple in relation to the networking stuff, I think. But anyway, I've created a list here for some weapons that I want to implement, and I think in the near future, maybe even, I will start making some of those. Yeah, I really like the project. I really liked, in my childhood, I really liked to play such games as Warmix in Vkontakte and Worms on my mobile phone. Yeah, so I'm really a fan of such games, and I think if I try and if I come up with something interesting, I think this game can be successful and can be interesting to play with your friends or something like that. Yeah. So yeah, I think I will stop for today. It was a good time implementing those things. Thank you for watching, Rish, and yeah, I hope to see you soon. Goodbye. Goodbye, my friend.